Okay, so elimination method is what we're talking about today. Again, systems of equations are still two or more equations with the same variables, and we're looking for solutions that will satisfy both of the conditions, okay, not just one of them, but both of them. So the strategy that we're going to use is the elimination method today. So yesterday we did substitution, today we're going to do elimination. And this strategy allows us to add our equations together to get rid of a variable, okay? So we're going to look here at this equation. Y is equal to 3x plus 4, y is equal to x minus 2. So what we need to do here is create a magic number that's going to allow us to get rid of one of these variables. So I want to get rid of the x here. So what I'm going to do is I am going to multiply this second equation by -3. That's going to be my magic number. So my first equation is still y equals 3x plus 4. The second one, I'm going to multiply everything by -3. So -3 times y is -3y, -3 times x, -3x, -3 times -2 is positive 6. And then I'm going to add these two equations together. So 1y plus -3y is -2y. 3 plus -3 is 0. And 4 plus 6 is 10. And so now to solve, we just divide by -2. And so we find that our y value here is -5. Remember that once you know the y value, all you have to do is plug it back in to find the x value. So I'm going to plug it into either equation. I'm going to plug it into the bottom one. So instead of y, I'm going to plug in -5 is equal to x minus 2, and then I'm going to add 2 to both sides. And I find that x is equal to -3. Okay, so now that we found two solutions, we need to make sure that our solutions work. So we're going to take the first equation and we're going to plug those two numbers in. So y is -5, x is -3, and we're going to solve. -9 plus 4 is -5, so that one works. First condition has been met. And then the second equation, y equals x minus 2. So y is -5, x is -3, -3 minus 2 is -5. So that condition has been met as well. So our final answer on this is -3 is x, -5 is y. And remember that we have an x and a y, so we can write that as an ordered pair. Okay? All right, so let's look at number 2. All right, so number 2, we have x plus 4y equals 13 and x minus y equals 3. The magic number that I'm going to choose here is 4. So hopefully you're starting to pick up on the magic number and how we're choosing it. So I'm going to choose the magic number 4. So x plus 4y equals 13 is still my first equation. The second one, 4 times x is 4x. 4 times -y is -4y. 4 times 3 is 12. Okay? And then we are going to add these two equations together. So x plus 4x is 5x. 13 plus 12 is 25. And then we are going to divide by 5 and find that x is 5. So that is the first variable. Now we can plug this back in to either equation to solve. So I'm going to plug it back into the first equation. 5 plus 4y is 13. I'm going to subtract my 5. 4y is 8. And then I'm going to divide by 4. And so y is 2. And so now that we have two solutions, we're going to check and just look to see whether or not they're the right numbers or not. So x plus 4y is equal to 13. If x is 5 and y is 2, 5 plus 8 should be 13, and it is, so that condition is met. Second equation, x minus y equals 3. X is 5, y is 2, and if I subtract them, I should get 3, and I do, so it works. So here our solution is 5 and 2. Okay? All right, Sorry about that. I keep moving and the sun is causing a glare. All right, let's try that again. Let's do number 3. All right, so on number 3, we got a couple options here, but let's go ahead and use -1 as a use -1 as our magic number. And yeah, I can do -1 to the first equation. So let's do that. So the first one, -1 times 3 is -3x. -1 times -10 is positive 10y. -1 times 14 is -14. And then the second equation stayed the same, so 3x minus 9y is equal to 15. And then we're going to add that together. -3x and 3x is 0. 10 and -9y is y. -14 and 15 is 1. So we find that y is equal to 1. We didn't even have to do any solving on that one, so that was kind of nice. So now I'm going to plug that back into one of these equations and find x. So I'm going to plug it into the bottom one. 3x plus minus 9y is equal to 15. So 3x minus 9, I'm going to multiply y, 9 times 1. And so I get 3x minus 9. I'm going to add that 9, and I get 3x is equal to 24, and divide by 3, and I find that x is 8. So I need to check myself and make sure that that works. So we have 3x minus 10y equals 14. If x is 8 and y is 1, then we should get 24 minus 10 should be 14. And it is, so that one works. Second condition is the second equation. 3x minus 9y equals 15. So 3 times 8 minus 9 times 1 is supposed to equal 15. 24 minus 9 does equal 15, so that works. So our answer here was 8 was x and 1 was y. Okay. And then we've got one more example before we do a word problem. So on this example, let's do a magic number of 2 on the bottom here. Okay, so I end up with 4x plus 2y equals 6. That's still the first equation. Nothing has changed. The second one, 2 times -2 is -4x. 2 times 2y is 4y. And 2 times 18 is 36. And so then we're just going to add these two things together. 4 and -4 is 0. 2 and 4 is 6. And 36 and 6 is 42. And then just to solve for y, we divide by 6. And we find that y is 7. Then we're going to plug that into one of the equations. Doesn't matter which one. We'll plug it into the first one. 4x plus 2 times 7 is equal to 6. So 4x plus 14. We subtract 14. And then we divide by 4. We find that x is -2. Okay? And so now we just need to check and make sure that those work. So first equation, 4x plus 2y is equal to 6. I plug in x is -2. Y is 7. And that's -8 plus 14, which works. And then -2x plus 2y equals 18. Plug in those two numbers again. We get 4 plus 14, which does equal 18. Okay, so we find that our answer here was -2 and 7. Okay, x is -2, y is 7. All right, so now let's get back into the idea of a word problem again. All right, so here we have information that Aaron bought 4 jars of jelly and 6 jars of peanut butter, and it was $19.32. Adam bought 3 jars of jelly and 5 jars of peanut butter for $15.67, and we are asked to find the cost of a jar of peanut butter. Okay, so we've got two conditions. We've got the trip to the grocery store that Aaron made, and we've got the trip that Adam made. And we need to use that information to find the cost of a jar of peanut butter. So we know the number of jars of jelly and peanut butter that they bought. What we don't know is the cost of each jar. So that's what our variables are going to represent this time. So let's say J is equal to the cost of a jar of jelly, and P is equal to the cost of a jar of peanut butter. Okay, that's the variables that we're going to use. So let's just go ahead and create ourselves two equations. So 4 jars of jelly at some cost, so 4 multiplied by the cost, plus 6 jars of peanut butter, so 6 multiplied by the cost, that P, is going to total $19.32. And then down here, for Adam's trip, 3 jars of jelly multiplied by the cost of the jelly, plus 5 jars of peanut butter multiplied by the price of a jar of peanut butter, was equal to $15.67. So here are our two equations that we're going to use. Okay, so in this situation, I'm going to need two magic numbers to make this work. And so in order to do that, I'm going to multiply the first one by 3 and the second one by -4. Okay, and then that's what I'm going to use to create my new equations. So that's what I'm going to do up here. 3 multiplied by all of this. So 3 times 4j is 12j. 3 times 6p is 18p. And 3 times 1932 is 5796. Okay, and then down here I'm going to multiply everything by -4. So -4 times 3 is -12j. -4 times 5p is -15p. I'm sorry, it's -20p. And -4 times 1567 is -6268. Okay, so now you see that I have created two equations where I can actually eliminate one of the variables. That's the joy of these magic numbers. So now I can add these two things together. So 12 and -12 becomes 0. 18 and -20p is -2p. And 5796 plus -6268 is -$4.72. Then we can divide by -2, and we find that P is equal to 236. So we found one of those numbers. So now we need to find the other one. So we're going to plug it into one of these equations. So I'm going to pick the first equation. 4j plus 6, and I know that P is equal to 236, so that's what I'm going to plug in. Sorry, 236. And that's equal to 1932. And so I'm just going to solve this. When I multiply 6 and 236, I get 1416. And then I'm going to subtract that, and I get 516. And then I'm going to divide by 4, and I find that j is equal to 129. Okay? And so now the last step that I need to do is check myself, make sure that all of these numbers work. So 4 jars of jelly at 129 a jar plus 6 jars of peanut butter at 236 a jar is supposed to equal 1932. And so 4 times 129 is 516, and 6 times 236 is 1416, and that equals 1932. So that one works. And then the second one, 3 jars of jelly at $1.29 plus 5 jars of peanut butter at $2.36 should total $15.67. So 3 times 129 is 387, and 5 times 236 is 1180, and together that equals 1567. So that works as well. So both conditions have been met. Aaron's trip works, Adam's trip works, and so now we just need to find our final answer. And the cost of the jar of peanut butter is what we're asking for. So the cost of a jar of peanut butter, okay, that's P. P is the cost of a jar of peanut butter, is $2.36. And so this right here is my final answer. I'm sorry, I ran off the page there. The cost of a jar of peanut butter is $2.36. All right. So we're going to talk through a couple of examples in the next page, and this has been a long video, and then I'll let you guys get started on some practice problems on your own.